Morning students. Now in the last lecture we have read the rules for properties of rational number in case of addition, subtraction, multiplication and division. Some of the properties are closure property, associative property and commutative property and identity property. So in some of the operation all these property not hold good. Now we'll solve some examples on the rational numbers. Now these are rational numbers minus 3 upon 8, 4 upon 5 and 1 upon 4 that we have to arrange in the ascending order. So their denominators are not same. So first we have to make denominator same. To make the denominator same we have to find out the LCM. So LCM already you are knowing how to find out the LCM of 8, 5 and 4. It will come 40. The LCM of 8, 5 and 4 which are not equal denominator, that we have to make the LCM 40. So every denominator should make 40. So to make the denominator 40 here, we have to multiply by 5 because 8 5 is 40. Or you divide by the denominator to this LCM. Whatever quotient is given, by that number you have to multiply. So 5 8 is 40. So here you have to multiply by 40 and here 4 10s are 40. Now, not only we have to multiply to the denominator, we have to multiply to the numerator also. So 5 3s are 15, that is minus 15 upon 40, comma 8 4s are 32, that is 42 upon 40, and last 10 1s are 10 upon 40. So in this way, the denominators of the given rational numbers are not same, that we have made the denominators equal by taking the LCM and by using the equivalent fraction property. If we multiply or divide to the rational number by any number, then it's called as equivalent fraction. So we got the fraction minus 15 upon 40, 32 upon 40 and 10 upon 40. Now you have to arrange this in the ascending order. Ascending order means from smaller to the greater. So always the negative number is always smaller. So first will come minus 15 upon 40. Then second will come 10 upon 40. And third will come 32 upon 40. Now this we have made the equivalent rational number. Now we have to see which is the original number of this. So minus 15 upon 40. The original number is minus 3 upon 8. So this is minus 3 upon 8. 10 upon 40 means 1 upon 4. And 32 upon 40 is 4 upon 5. So in this way, we have arranged this given rational number in the ascending order. That is first minus 3 upon 8, then second 1 upon 4 and 4 upon 5. It is very easy. You have to make the denominators equal by taking the LCM. You will get the real rational numbers which with equal denominators. Then you arrange from smaller to greater. And now your example which arrange in ascending order, that answer is minus 3 upon 8, 1 upon 4 and 4 upon 5. So in this way we can arrange the rational numbers in ascending order. Now we see the second example to arrange the rational numbers in descending order. So 3 upon 9, then minus 1 upon 6, then minus 7 upon 12. So these are the rational numbers which you have to arrange in the descending order. Ascending order means from smaller to greater. Descending is from greater to smaller. Here again, the denominators are not same. Here 9, 6 and 12. So you have to make the denominator equal, means you have to find out the LCM. I will show how we are finding the LCM if anyone is not knowing this. So LCM we have to find out like this. So 3 3s are 9, 3 2s are 6, 3 4s are 12, 3 1s are 3. Here we cannot divide, so 2. Here we cannot divide, so 4. So here comes 1, so it is finished. Now 2. Here 1, 2 1s are 2, 2 2s are 4. So here and here come 1. So last step now 2, 1, 1, 1. So everywhere in the column comes 1, 1. So you have LCM you have to take now. LCM is equal to, you have to multiply 2 2s are 4, 4 3s are 12, 12 3s are 36. So LCM of this number 9, 6, 12 is come 36. Now we have to make denominator equal. So to make the denominator equal, here 9 for the 36. So you have to multiply to the first rational number, which is 4, minus 1 upon 6. 6 6 are 36. So here by 6, and 12 3 are 36. So here by 3. So in this way we can make the equivalent rational number. 9 for the 36, 6 6 are 36, 12 3 are 36. Now we will multiply 4 3 are 12 upon 36, comma, minus 6 upon 36, and comma, minus 21 upon 36. So this is the now rational number which is in the equivalent to the first. Now we have to write in the ascending order. So descending order we have to write, not in the ascending. Descending order we have to write. Descending order of this BO means descending order. So first will come greater. So these both are negative, so they are smaller. So which is the positive? That is the greater. So that is 12 upon 36 is the first. This is the greater. Now which is coming first on the left side of 0, that is greater. So first is coming minus 6 and afterward coming minus 21. So minus 6 is greater than minus 21. So minus 6 upon 36, and last will come minus 21 upon 36. So we have arranged this according to descending order from greater to smaller. Now we write in the original form. So 12 upon 36 is the 3 upon 9. So descending order 3 upon 9. 12 upon 36 is 3 upon 9. Minus 6 upon 36 is minus 1 upon 6. Sorry. Minus 1 upon 6. And minus 20 upon 21 upon 36 is minus 7 upon 10. So in this way, we have arranged them in the descending order. Descending order means from greater to smaller. So 12 upon 36 is 3 upon 9. Minus 6 upon 36 is minus 1 upon 6. And minus 7 upon 12 is, minus 20 upon 36 is minus 7 upon 10. So in this way, we can arrange the given rational numbers in ascending and descending orders. So we see some different types of examples from the rational numbers. A car covers a car covers 12 integer 3 upon 2 kilometer in 3 integer 1 upon 4 hours. Find the speed. The example is a car covers 12 integer 3 upon 2 kilometers in 3 integer 1 upon 4 hours. Find the speed. You have to find out the speed of this car. So first we'll write what is given. Car cover, so distance is given 12 integer 3 upon 2. So we'll convert it to the fraction. We have to multiply by denominator this integer. 12 2s are 24 plus 3, that is 27 upon 2 kilometer. So this is the distance given. Now in 3 integer 1 upon 4 hours, so time we have given. Time is equal to 3 integer 1 upon 4. Again we have to multiply to the integer by denominator. 4 3s are 12 plus 1, that is 13 upon 4 hours. So we have written distance and time. Now we have to find out the speed. The formula is speed is equal to distance upon time. This is the formula for speed. Speed is equal to distance upon time. Now distance already we are knowing. Distance is 27 upon 2 divided by time. Time is 13 upon 4. So we are finding the speed. The formula is distance upon time. The denominator means divide. So distance is 27 upon 2 divided by 13 upon 4. Now already you are knowing in the fraction when divide is there we have to make multiply. So 27 upon 2, this divide becomes multiply and you have to take reciprocal of this. Reciprocal means the 4 will go into the numerator, 13 will come into the denominator. So 4 upon 13. Now here cancellation is there. 2 1s are 2, 2 2s are 4. Now there is no any further reduction. We cannot cancel 13 and 27. So 27 2s are 54 upon 13. 27 2s are 54 upon 13. And we have asked the speed. So speed is given in the unit kilometer per hour. So speed of that car is 54 upon 13 kilometer per hour. We are given the distance 12 integers 3 upon 2 that we are current to fraction. 12 to the 24 and 3 27 upon 2 kilometer. Time is 3 integer 1 upon 4. That is 13 upon 4 hours. We have to find the speed. So speed is equal to distance upon time. 27 upon 2 divided by 13 upon 4. Divide becomes multiply in division of rational number or fraction. So you have to take reciprocal. Reciprocal means numerator will go up and denominator will come down. So 4 upon 13. Here reduction is there. 2 1s are 2, 2 2s are 4. And further there is no reduction. So 27 upon 4. 27 2s are 54 upon 13. So speed of car is 54 upon 13 kilometer per hour. So in this way we can solve the examples on the rational number. Now we see next example of another type from these rational numbers. Divide the sum of 4 upon 9 and 5 upon minus 5 upon 6 by 2 upon 5 divide the sum of 4 upon 9 and minus 5 upon 6 by 2 upon 5 and 4 upon 3 sum. So your question is divide the sum of 4 upon 9 and minus 5 upon 6 by 2 upon 5 and 4 upon 3 sums. So first you have to do the addition of these two rational numbers, sum means also addition, and then you have to divide. So first we solve the sum of this 4 upon 9 and minus 5 upon 6. So 4 upon 9 plus minus 5 upon 6. Now here LCM is 18. 9 and 6 LCM is 18. So to make the denominator 18, here 9 2s are 18 and here 6 3s are 18. So 2 4s are 8 plus denominator will become 18. 3 5s are 15, but that negative sign. So minus 15 upon 18. So 2 4s are 8 plus 3 5s are 15, but that product of positive and negative is negative. So minus 15 upon 8. Now denominator become equal, we can add, but here signs are different. So take the difference. 15 minus 8 is 7, and that is sign of greater integer. So minus 7 upon 8. So first sum is minus 7 upon 8. Now second sum you have to find out, that is 2 upon 5 plus 4 upon 3. This is the second sum of you have to find out. So here denominators are not same, so you have to make the LCM. So LCM is 15. As both are the prime numbers, so product of their prime number is only when both are prime numbers, their LCM is product of them. So 5 3s are 15. So here you have to multiply by 3, 5 3s are 15, and here by 5, 3 5s are 15. So that denominators become equal. 3 2s are 6 upon 15 plus 5 4s are 20 upon 15. And both are positive, so 20 plus 6, that is 26 upon 15. So second addition or sum is 26 upon 15. Now you have to divide the sum of this sum is to divide by this sum. So minus 7 upon 8 divided by their sum is 26 upon 15. You have to divide the first sum. Divide the sum of following by 2 upon 5 this. So minus 7 upon 8 divided by 26 upon 15. So minus 7 upon 8 divide becomes multiply. So we have to take reciprocal. So reciprocal means numerator will go into denominator, denominator will go into numerator. So 26, 15 upon 26. Now in this number there is no any numbers or no any two numbers, they are coming in the same table, so no common is there, so directly you have to multiply. So product of negative and positive is negative, so 15 7s are 105, that is minus 105 upon 26 8s are 208. 15 7s are 105, negative sign upon 208. So answer of this, divide the sum of 4 upon 9 and minus 5 upon 6 by 2 upon 5 and 4 upon 5 sum. So first we add this sum, answer we got minus 7 upon 8, then this sum we are done, that is 26 upon 15, then first sum is to divide by second, so minus 7 upon 8 divided by 26 upon 15. We are change divide to multiply and take the reciprocal. There is no any common factor between them, so we multiply. The answer comes minus 105 upon 208. In this way, we can solve the different examples based on the rational number. We'll solve next example from this chapter. Rajesh take 2 integer 1 upon 3 hours. Rajesh take 2 integer 1 upon 3 hours to complete one round to the park. How many hours will he take? How many hours he will take to complete complete 6 rounds? Rajesh takes 2 integer 1 upon 3 hours to complete one round to the park. How many hours he will take to complete 6 rounds? Now he is completing one round around the park in 2 integer 1 upon 3 hours. So we write this: for one round 2 integer 1 upon 3 hours means 3 to the 6 plus 1, that is 7 upon 3 hours. Now like that he has to complete 6 rounds. So time for 6 rounds is equal to, for one round he is taking 7 upon 3 hours, we have to find for 6 hours. Now from one you are finding for many. So from one, when we have to find for many, it is taken as the multiplication, and from many to one it is doing as the division. So from here, one round we are finding the time for 6 hours, 6 rounds, so we have to make the multiplication. So 7 upon 3 multiplied by 6 upon 1. So 3 ones are 3, 3 twos are 6. So 7 twos are 14. So we will take 14 hours to complete 6 rounds. 14 hours he will require to complete the 6 round. For one round, he is taking 2 integer 1 upon 3 hours, means 3 to the 6 plus 1, that is 7 upon 3 hours. Time for 6 round, he is taking 6 rounds. So from 1 to we have to find out many, so we have to do multiplication. So 7 upon 3 multiplied by 6 upon 1. 3 1 are 3, 3 2 are 6. So 7 to the 14. So he will take 14 hours to complete 6 rounds. So in this way, small examples which are based on the multiplication, division, addition, subtraction, that we can solve in the type of word problem. Now next we'll see length of rectangle. 6 integer 1/2 meter and breadth 2 integer 2 upon 5 meter. Height, area and perimeter. You are given length of rectangle 6 integer 1 upon 2 meter and breadth is 2 integer 2 upon 5 meter. Find area and perimeter. So first we write length of rectangle 6 integer 1/2. So that is 6 to the 12 plus 1, that is 13 upon 2 meter. Breadth, that is 2 integer 2 upon 5. So 2 integer 2 upon 5, that is 5 to the 10, 10 to the 12, 12 upon 5 meter. So first we have written, which is in the improper fraction, mixed fraction, that we have made improper. So 13 upon 2 meter is length and breadth is 12 upon 5 meter. Now you have to find out the area of rectangle and perimeter. So area of rectangle formula is length multiplied by breadth. This is the formula for area of rectangle that already you are knowing. From 5th standard you have read this. So length is 13 upon 2 into breadth is 12 upon 5. Now there is no any cancellation for that. So 13 12 are 12 3s are 36, carry 1, 12 3, 12 1s are 12 and 3 15. 13 12 are 156, 12 3s are 36, carry 3, 12 1s are 12 and 3 15, and 2 5s are 10. And unit is, this is area, so both are in meter. So it is meter square or square meter. Now we can write in the decimal form also. When we are dividing by 10, you have to give one decimal point from right hand side. So we can write the answer in the decimal 15.6 meter square. So area of rectangle is either you can write 156 upon 10 meter square, or we can write the other way 15.6 meter square. Now you have to find out the perimeter. So perimeter is equal to 2 into bracket length plus breadth. You have to find out the perimeter. So perimeter of rectangle is equal to 2 into bracket length plus breadth. So is equal to 2 into bracket, length is 13 upon 2 plus breadth is 12 upon 5. Here length is 13 upon 2, breadth is 12 upon 5. As denominators are not same, so you have to find out the LCM. So LCM is coming 10. So here you have to multiply by 5, here you have to multiply by 2. So 13 5s are 65 upon 10 plus 12 2s are 24 upon 10 into 2. Denominators are not same, so we have to find out the LCM. So LCM is 10. So 10 means 2 5s are 10, 5 2s are 10, 13 5s are 65, 12 2s are 24. So both side denominator become same. Now we'll add 2 into bracket. This 5 plus 4 9 and 6 2, 6 plus 2 8. So 89 upon 10. And between the bracket and the number, sign is not there, so sign is multiplied. So we have to multiply 2 into 89 upon 10. So here we can cancel 2 1s are 2, 2 5s are 10. So 89 upon 5 meter is the perimeter of given rectangle. Here this is, maybe you can find this a little bit difficult. The perimeter is given by the formula 2 into bracket length plus breadth. So 2 into bracket 13 upon 2 plus 12 upon 5. So 13 5 are 65 upon 10. 2 12 are 24 upon 10. Addition of these two denominators are same, so we can add. So 5 plus 4, that is 9, 6 plus 2, that is 89 upon 10. And outside the bracket 2 is there. Between the bracket and fraction there is no sign, so sign is multiplied. So 2 upon 1 multiplied by 89 upon 10. 2 1s are 2, 2 5s are 10. So 89 upon 5 meter. It is the perimeter of a given rectangle, and area of rectangle is 156 upon 10 meters square, or 15.6 meters square. So in this way, any type of example regarding geometry or fraction, addition, subtraction in case of rational number, we can solve by using these methods. Now we'll see next example from this. This is the next example from this one more, so you can get the idea of this, how to solve. Find the three rational numbers between 2 and 3. So you have to find out the three rational numbers between 2 and 3. So in previous some lecture I told you how to find out. One more time I am writing or doing that example. To find the rational numbers between 2 and 3, the formula is a plus b upon 2. A is 2 and b is 3 upon 2. So first we'll take 2 plus 3 upon 2. So here 2 plus 3 is 5 upon 2. So first number you get between the 2 and 3 is 5 upon 2. Now second number to find out, you have to take the addition of 2 and 5 upon 2. So second 2 plus 5 upon 2. Here denominator is not there, so 1. If denominator is 1, then you can, denominators are not same and one denominator is 1, you can do direct cross multiplication. So 2 2s are 4 plus 1 5 is 5 upon these 2. So 4 plus 5, that will come 9. 4 plus 5 upon 2 divided by 2. So it will come, this divide becomes multiply. So 9 upon 2 into 2, that is 9 upon 4. So second number between the 2 and 3 is 9 upon 4. For finding the next rational number between these, we have taken the first number 2 upon 1 plus this 5 upon 2 and divide by 2. So denominators are not same. One is denominator, so we have taken the cross multiplication. So 2 to the 4 plus 5 upon 2, that is 9 upon 2, and this divide 2 becomes multiply up. So 9 upon 4. Now we have to find out the third. So we can take this 9 upon 4 and 3 also, or same number 2 plus 9 upon 4 upon 2. So here also denominator is 1. So here denominators are not same, so you find out the LCM by taking the cross multiplication. So 4 to the 8 plus 9 1 the 9 upon 4 divided by 2. So 8 plus 9, that is 17 upon 2, and this divide becomes multiply. So this is 17 upon 4 and this 2 is divide, that becomes multiply up. So 4 into 2, so 17 upon 8 is the third number. Here first number is 2 upon 1, then second number between is 9 upon 4 divided by 2. Denominators are not same, so we have taken the cross multiplication. 4 to the 8 plus 9 upon 4 divided by 2. So 8 plus 9, that is 17 upon 4, and this divide becomes multiply. So 4 into 2, that is 17 upon 8. So in this way we have find out the three rational numbers between 2 and 3, that is 5 upon 2, 9 upon 4 and 17 upon 4. Enough. So in this way we have solved today the different examples from rational number. Thank you.